need to understand that we have different types of numbers. Okay, we have what we call natural numbers, we have what we call whole numbers, we have integers, we have rational numbers, we have irrational numbers, real numbers, and also complex numbers. So let's start by understanding what natural numbers are, okay? These are counting numbers. A natural number starts from 1 itself, okay? It starts from 1. And it is a set of natural numbers like 1, 2, 3, 4, 5, 6, 7, whatever. Okay, all the count numbers that you know are natural numbers. Okay, and when 0 is included in the set of natural numbers, they are called whole numbers. All right, so the difference between whole numbers and natural numbers is that whole number starts from 0, natural number starts from 1. Natural numbers that are divisible by 2 without leaving a remainder are called even numbers. Okay, so any number which are divisible by 2 and do not leave a remainder are all called even numbers. So now, when you have numbers, okay, when you have numbers that are not divisible by 2, then those numbers are odd numbers, like 1, 3, 5, 7, 9, okay, all those numbers that leaves a remainder, or I mean the numbers that are not divisible by 2, okay, are called odd numbers. Let's look at integers. What are integers? So integers are both positive and negative numbers, okay?
Take note that 0 is an integer, but it's neither a positive or negative.
Okay, so this is an example of integers. This is a symbol for integers. Z is a symbol for integers. Okay, so these are some of the examples of integers. Okay, so any number that can be written as a ratio is a rational number. Now, in rational numbers, both the denominator and the numerator are whole numbers. So in irrational numbers, the number on when you're dealing with fractions, right, the number on top, which is called the numerator, and the number at the bottom, which is called the denominator, are whole numbers, and all whole numbers are rational numbers. So examples of rational numbers, we can have a 4/5, 7/1, okay? We can have all these examples of fractions which happens to be rational numbers.
1/3 is 7/12. Each of these are numbers, but we don't use them as often as we use counting numbers. Such numbers are called rational numbers, but we need to define them well. We cannot say numbers like these are rational numbers. We say that they are of the form p/q, one number in the numerator and one in the denominator. But there are a few conditions we need to know. P and Q should be integers. We can have only integers in place of P and Q. And there is another important condition. Q should not be equal to 0. Why do we have the second condition? Say I ask you to calculate 3 divided by 0. What would be the quotient? 0 multiplied by what will give you 3? There is no such number.
So, an irrational can be written as a decimal, all right? Not as a fraction. So that is the difference. A rational number is written as a fraction, okay? But an irrational number is written as a decimal. For example, we can take an example of a pi, which is 3.14159, blah, 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 okay? Meaning that it's an irrational number. We can also take an example of, an example of a pi, which is 3.14159, blah, 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 okay? Meaning that it's an irrational number. We can also take an example of an example of a pi, which is 3.14159 blah 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 blah. Okay, meaning that it's an irrational number. We can also take an example of let's try to check what irrational numbers and irrationals are. Let's say, for example, square root of 9. When you calculate the square root of 9, you are going to find that the answer is 3, and 3 is an integer, and integers are rational numbers. So because we've gotten that, then that means 9 is a rational number. The square root of 7, when you calculate on your calculator, the square root of 7 is not going to give you an integer, it's going to give you a decimal and an infinite one, which is 2.645755131, and it continues like that. Okay, so that just means the square root of 7 is an irrational number because it's a decimal that does not end. Okay, so that is how you identify irrational numbers from rational numbers. Okay, let's also check pi. When you calculate pi on your calculator, you're going to find that it's also going to give you a decimal that does not end. Okay, 3.1415926 blah 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 blah. Okay, that just shows that a pi is also an irrational number. The other one is e. When you calculate e also on your calculator, you're going to find that it will be a decimal that does not end. So that is how it is. Integers, okay, rational numbers and irrational numbers constitute the set of real numbers. And real numbers can be used to label every point of continuous line the real numbers minus the real numbers. Any numbers that can be put on a number line, okay? All integers, since all integers are real numbers, and then you also need to know that you can be able to tell what real numbers are by first understanding what imaginary numbers are. So imaginary numbers, this is where you see a number next to an I next to a number. Like you can see 5i, 3i, I, and I is same as the square root of -1, meaning the square root of -1 cannot be put on a number line. Okay, we have maybe, let's say, -4, the square root of -4, which is equal to 2i, all right, which is also not a real number. So all these numbers that have I, then as long as you have such numbers, just know to say these are imaginary numbers and they are not part of the real numbers. So real numbers consist of what we've talked about, which is the rational numbers and also the irrational numbers. So when you put these numbers together, the irrational numbers and the rational numbers and the irrational numbers, then you come up with what we call the real numbers.